Today is November the 10th, 2015. This is a second follow-up to the replacement of the capacitors in the old Macintosh amplifier last night. These guys right here. And I think I have a very reliable way to test these capacitors for leakage. It's pretty simple. The capacitors we're trying to test are these guys right here, the coupling capacitors. Because see, you've got high voltage. You can have 300, 400, 500 volts down here going through the plate load resistor of this stage, which is driving this stage. And you want the AC component, the signal component, to go through, but you don't want any DC leaking through because it'll change the bias voltage over here on this grid. So this guy right here cannot leak DC. So the test setup I have is that Keithley high voltage power supply that I can get up to 1,000 volts on. I'm going to test each capacitor at its rated voltage, and it's very simple. I'm just putting the capacitor in series with a 20 microamp meter movement. Now this is a beautiful little 20 microamp meter movement, so I've got a short that I can place across it while I'm running this voltage up, so as not to be slamming this thing. I don't want to destroy this meter for no good reason. So when I first connect it up and turn the high voltage on, there'll be no reading, and then I'll remove one of the leads from the short across it, and then we'll actually get a reading, and it'll help protect my meter. So let's try it. Let's get busy here. Okay, I've got the power supply over here set for 0. This is the 100 volt adjustment right here, so I'll just run it up in 100 volt steps. The first capacitor, I've got some that leak. The first capacitor we'll test is a brand new, this is a 0.47, and it's rated at 600 volts. This is a, let me show you here. This is a nice new orange drop, 0.47, 400 volt. Okay, we'll test it at 400 volts. We'll put it across here, just in that circuit I was showing you. I've got the meter shorted right here with this green lead. I'm going to run it up to 400 volts. 1, 2, 3, 4. There's 400 volts. Of course, I got to be careful. This thing will knock me on my butt. Then I'm going to remove the short across the meter. Voila, nothing. Now you're saying, yeah, right. Does this thing actually do anything? See, it's still dead zero. Okay, let's turn this thing back off. Let's put a capacitor in. I'm going to short it again, because like I said, I don't like to slam my meter around. Let's put a capacitor in that does leak. Here's a 047. If I can see what I was doing. A 047 Bumblebee, rated at 400 volts. Let's put 400 volts on it. 1, 2, 3, 4. And then let's remove the short of the meter. See, that one is leaking even more than 20 microamps. Peg the meter. It's not horrible. It's certainly not a short, but it is leaking pretty bad, isn't it? Okay, so we would call that capacitor right there bad. We would. I got nothing against little bumblebees. These things there's bazillions of these things out there. When you consider, just because you can find one bad one doesn't mean that we want to malign them all. Some people pay big bucks for these things because they want to make their stuff original again. Let's test another one. It's another, this one is a 0.1 400 volt. 1, 2, 3, 400 volts. Well, there it is, leaking right there. I guess I didn't have this thing properly shorted. There it is, shorted. It's going to go to 0. But when I take the short of the meter off, so we're actually measuring current through the meter. See, it's measuring about 9 microamps. If you can read that, I hope you can. That one's leaking. Not as bad as this one, but it is leaking. Turn the high voltage. Yep, see, that's why I don't want to short this thing. I don't want to damage my beautiful little meter. See, it's actually new. It came out of this box right here. We'll triplet 20 microamp meter. Here's a 0.47 that came out of that amplifier. These two right here did not come out of the amplifier. These are just some that I have. Here's the 0.47 that came out. This was the first capacitor, and it's rated at 200 volts. So we're right up to 200, and we'll see that it leaks a little bit. Not really bad. leaking about, oh, if you read that, that's 4, 5, 6, 6.5 microamps. Okay, so we would call these bad. We would not want to use them. I have lots of these old capacitors, boxes of these things I've saved. Probably most of them are good. I have tested a few of these and they are good. They do not leak. Here's another little box of the Bumblebees. I've tested several of those and they're fine. The Black Beauties, I believe, as they are known. Some of these little imp capacitors, they're actually pretty good too. That in 1600 volts, it probably won't leak. But I think that's a legitimate way to test them. If they don't leak, they don't leak. What else can I say? And this is pretty sensitive. I mean, we're able to measure down to a fraction of 1 microamp of leakage current. Now, I was asked, did I believe in the mojo of carbon resistors? The answer is no, I don't. I think that you get a good carbon resistor, you get a good metal film or whatever kind of resistor you want to use at audio frequencies is not going to make any difference. Now, I never have actually tested resistors up at RF, but I believe a simple carbon resistor put in like a dummy load will exhibit a pretty flat response, pretty resistive response, all the way up to about 300 megahertz. Pretty high. So we're not dealing with anything even remotely close to 300 megahertz in an audio circuit. So yes, I do have in my hands here, make sure that thing is off, I do have 3 leaking Bumblebees. Here, let's just test one more. What about one of these big guys? This is a big 600 volt 0.22 spray Black Beauty. Let's put it in there and test it at 600 volts. 1, 2, 3, 4, 5, 6. And then take the shunt off, and there it is. Well, look at there. There is a tiny amount. I didn't see that a while ago. Well, it's going down. It's less than, it's about, well, about 0.2 microamps. Tiniest amount. If you can see that off of 0. Let's get that. Let's look at this guy close. Hopefully it'll focus there. Nope. I don't want to focus that close. There it is. It's about as close to 0 as we can get. But it did show a little bit of leakage there for a second. Okay. Let's put this guy back on. Let's turn our 600 volts off, or you'll see me knocked against a wall. I really can't think of anything else to do here. Here's some 0.015 at 1600 volts. I can't run it up to 1600. I can run it up to 1000. Let's see if this guy leaks at 1000 volts. Gotta be careful here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's run it up to 900 volts. We're used to making this too. And then let's take our shunt off. Nope. See there? Did it move? It might have moved a tiny bit. Might be down there in the nanoamps, where it might have just charged. Let's see, the shunt's on there now. Let's take the shunt off. I think I saw it just microscopically move. I would not call that leaking. That's 900 volts across that capacitor. Okay, so that's that. Yeah, the capacitors that I use, I have a drawer full of them over here. I'll show you. I use these guys right here. This is what I use to replace the ones in the old Mac amp. I'm actually pretty fond of these orange drop caps. These are the 0.47s, 22s, 0.1s, 047s, 022s, and downward. I keep a number of them around for my hobby. I just hate to be building something and have to stop and order a capacitor. Well, that's all I can think of at the moment. But yeah, some of them do leak. We can detect it. Just put some high voltage, being very careful. You could even use the high voltage power supply out of your amplifier. It's usually up 450, 500 volts. You got to be careful. If you're not familiar, if you're not experienced working with high voltage, there's a good chance you'll be careless and you'll get the fool knocked out of you. And after you do it once or twice, you will know that you don't like it, and you'll start being very, very careful. Working with one hand in your pocket, being extremely careful. Don't be talking to people and jabbering. Don't have your cell phones go off in your pocket so it'll scare you, and telephones ringing and people banging on your door and distracting you. You shouldn't be working on high voltage when you're distracted by talking with other people. It's easy to be careless and get blasted. Hope this helps.